This chemical here, this is not blue Powerade. This is actually a substance that you worked with in grade 9 in a few of your labs. This is copper sulfate. Now, if you remember back, it's sulfate, not sulfide. The ending's different here, so that would imply that there's something different than, copper sulfide with which we've been working with so far. And in fact, there is. So let's take a look at what's going on here. Now, you might have some friends that, seem inseparable. Whenever you see one, you see the other group of friends. They finish each other's sentences, they're never apart. You call one of them on the phone, the other ones are right there with them. Well, there's some elements that kind of behave like that. They're a group of elements that will hang around together and have one overall charge for the entire group. So much so that we can actually treat them like a single individual element. And you have a list of them there on your handout right now. These guys actually aren't any trickier to name than the ones we've been working with so far. And in fact, in some ways, they may be even easier. Let's take a look at how we do this. Now, I have a few. Let's cut that and then we'll cut to this point. Here I have Li2SO4. Now, if you look at your sheet, find SO4 on there. What's the name of SO4? What does it say? Well, it says sulfate. So how do I name this? Well, I'm going to write down Li is lithium. SO4, the name for the entire group. I'm not going to try to say sulfur, oxygen, something, something. The name for the entire group is sulfate. So all I do is write down lithium sulfate. I have something here. This is a little bigger, a little messier. Mg3 bracket PO4 bracket 2. What is this? Well, I know Mg is magnesium. Magnesium. I look to my chart. You will always actually have this chart with you, even on tests and stuff like that, so you can relax a little bit. PO4, what's that? Well, that is phosphate. So I'm going to call this magnesium phosphate. Okay, so the ATE is just really a signal to me that we're talking about a group of elements rather than a single one. Now this one looks messy. We've got lots of elements here. So I see NH4, NO3. Now if I look carefully at my group, NH4 is actually the only group that we're going to worry about that acts like a metal. In other words, that has a positive charge and therefore would come first in a simple ionic compound. So here NH4 is ammonium. I look, NO3, what's that? Find it on my list. That's nitrate. So this is ammonium nitrate. And it's really that simple. There's a few on your sheet for you to try now. Give those a shot. Make sure to look at your chart because that's how you're going to figure these out. Okay, now naming polyatomic ions, the ones that have the groups, the 8s in their names, they're really actually not that much trickier than the ones we've done so far, and I think you're going to be pretty good at these. So what do? Well, the nice thing is we really follow the exact same steps we've been using so far. So if I have something like calcium nitrate, what do? Well, before I would write down the symbols, I would write down the charges. I do the exact same thing. So calcium, Ca, I look, 2 valence electrons, one's to lose them both, it's going to be +2. Nitrate, now I see the ATE that tells me go look at my list of polyatomic ions and find it. I look at my chart, you can take a look right now and see that it's NO3 -1. And this -1 charge is for the entire group, for the whole NO3. Now what would I normally do? Well, I normally crisscross. In fact, we do the exact same 3. 2 comes down, the 1 comes down. So, Ca, that's no big deal. But this is where sometimes students will get confused because they'll say the 2's coming down, but they already have a number right there. Well, that's 3 oxygens to 1 nitrogen in that group. So that's not really what we're showing. What we want to show here is we're going to use some brackets that now we have 2 of the groups. So anytime we have a number coming down, we're going to put it in brackets. So if it's not a 1, put it in brackets, put it outside. Calcium nitrate. All right, let's take a look at potassium carbonate. Okay, write down the symbols. K has 1 valence electron, charges +1. Carbonate, I look at my list, I see it's CO3, charges -2. Now I'm going to crisscross. Okay, the 1's coming down, the 2's coming down. K2. Now, because it's a 1, I'm only going to have 1 of the carbonate groups, so I don't need to put it in brackets. If I did put it in brackets, that would not be wrong, so maybe let's go through and do that. So CO3, bracket with a 1, but really, it would be simpler and easier just to write it K2CO3, potassium carbonate. Last one, let's take a look at this, aluminum phosphate. Al, I look at my periodic table, aluminum, 3 valence electrons, therefore its charge is going to be +3. Phosphate, PO4, the charge is -3. Got that again from my list. And you'll always have that list, so you don't have to worry about memorizing these. Now, I'm going to crisscross. 3 comes down, the 3 comes down. Al3, bracket, because at any time there's a number other than a 1, I'm going to put in brackets. PO4, bracket 3. Now, if I look, just like before, I have 3 aluminums and 3 phosphates. What do I want to do here? Well, I need to reduce. This is going to reduce down. 3 can come out of both of those. I'm going to get Al, PO4. So we've got to still watch and reduce. And this is probably about as hard as it's going to get until we combine it with one of the multivalent ones. And that will be a little trickier, but still very doable. All right, so there's a few examples there on your sheet. I want you to give those a try. Remember to look up on the list, use those charts of different polyatomic ions to help you out. All right, give those a shot. We'll take those up tomorrow.